Let me see if I can clear up some of the confusion about elimination. So you said that you're fine if the variables are already set up to eliminate for you. So let me just, I'm going to walk through this, make sure we're on the same page. So if you were doing this problem, you would notice that the y's are opposite signs, and they're also the same value but just opposite. So there's a positive y on the top and there's a negative y on the bottom. So the way they're set up right now, if I add these two, equations and I add them vertically, then 10x plus negative 7x is 3x. Or you can just think of it as 10 minus 7. And y minus y is going to be 0, so that's where the eliminate comes in. And then these two added together make negative 9. So then you would divide by 3 to isolate the variable, and you would get negative 3 for x. To find y, you would just plug this negative 3 into either equation. It doesn't matter whichever one looks easier for you. I'll go ahead and plug it into this bottom one. So I would get negative 7 times negative 3 minus y equals 18. The negative 7 times negative 3 would make positive 21. Minus y equals 18. And I can just think about that. 21 take away what equals 18? Well, that would be 3. So y equals 3. So then my ordered pair would be negative 3, positive 3. If I wanted to check those, those two x's, x and y should work in both equations and make them true. Okay, so I think we're on the same page on that. So let me try one where they don't match up. Okay, so these two don't match up. If you take a look at the x's, they're not going to cancel out if I add them together or if I subtract them. And neither will the y's. So I need to change one or both of the equations. And in order to change something, you can't change the value of anything. So what you do is it's a little trick. You multiply everything in the equation by the same value. So what I mean by that is pick either the x or the y's. And I'm going to pick the y's. The reason why I'm picking the y's is because I can see that one of them is 12y and one of them is 3y. And I know if I multiply 3 times 4, I get 12. So I'm going to pick those y's, and I'm going to take and multiply this whole equation by 4. That's the little trick that you can do so that they do match up. So if I multiply that by 4 all the way through, I'm going to get 12x plus 12y equals 27 times 4, 108. Okay, and the top equation is still 2x plus 12y equals 18. Now my y's won't cancel yet because they're both positive. They'll add up to 12y, but I can, and I did this on purpose to show you that if that happens, you can either go back and multiply by negative 4, or you can just go ahead and multiply a negative 1 through the whole equation. If you multiply by negative 1, it just changes all the values from positive to negative or from negative to positive. So if I do that, as long as I do everything, as long as I multiply everything in the equation by the same value, then I'm okay. Now if I add these two up, 2x plus negative 12 is negative 10x, and those cancel, which is what I wanted originally. Then, take away 18, then I get negative 90 over here, and I can go ahead and continue to solve. So I get x equals 9. Then I can do that whole step again where I take this and I plug it into one of those equations to get the y. So again, what I did is I looked at the equation at the beginning, and I thought about the x's and the y's and thought, what could I multiply one of the equations by so that it was the opposite? And again, I should have probably multiplied by negative 4, but I wanted to show you that other little trick. So let me put another one up here. So what I would do is I'll give you this problem and I would pause the video and see if you can figure it out on your own. And if you can't, play it a little bit just to get a start and then pause and try and do it on your own. So on this problem, I would be looking at the x's and y's, and in this one, the x's kind of seem like they're familiar. You've got negative 14x and negative 7x. So if I multiply the 7 by 2, I get 14. So I'm going to multiply everything, but I'm going to multiply it by negative 2 this time, because really what I want is positive 14 so that they'll cancel out or eliminate. So my new equation is going to be positive 14x, because negative 2 times negative 7x makes positive 14x. Then negative 2 times negative 5y makes positive 10y. And then negative 2 times 6 makes negative 12. And then I'm going to keep the top equation the way it was. I'm going to add these together. The x's, oops, that's an x. The x's are going to eliminate this time. I'm going to get 3y, because negative 7 plus 10y is 3y. 21 plus 12 is 9. And then I can divide by 3 and get y equals 3. And I can take my y and plug it into one of those equations to get the x. Okay? Then it gets a little bit harder. Sometimes the equations aren't set up so that they're in the same order. So like this problem, if I say 24 equals x minus 10y, and the other equation, if I say it's negative 16 minus 6y equals negative x. Notice that the top equation goes number equals xy. The bottom equation goes number minus y equals x. So they're not even in the same order. So you need to move one of them around so that they stack up, so the x's and the y's are right underneath each other. You can't just up and move this equal sign to here, so you can't do that. You've got to use inverse operations to move stuff around. So just pick one of the equations. Like I'm going to pick the top one. So I'm going to try and get the bottom one to match the top one. So what I want is I'd like to see this on this side. So I'm going to move it by using inverse operations. I'm going to add 6y to both sides. I'm adding 6y so that the 6y disappears on the left, reappears on the right. So I get negative 16 equals negative x plus 6y. So now if I take those equations and I rewrite it again, I have 24 equals x minus 10y. And the bottom equation I just changed to be negative 16 equals negative x plus 6y. Now I can do my elimination, and you can see that the x's are nicely stacked and they're perfect. They'll just eliminate and I can keep going. The hardest problems are where you have to where neither one of the equations match up and you have to multiply them both by something. So I made an extra video for that that's in the Sunberries video folder if you need, but I'll walk you through it right here. So the hardest example is something like this. Okay, so in this case, if I start to look at the x's, there's no way I can multiply something times 3 and get 4 without getting into ugly decimals. So that's not an option. So then I look at my y's. Well, there's nothing times 3 that makes 8 either. So then I'm looking at it thinking, okay, neither one of them will cancel. So what you do is you randomly pick an x or a y. I'm going to pick the x's. And I'm going to say, what can I multiply the top by? And then what number can I multiply the bottom by where both of them will be the same as the answer? So what I mean by that is like if I choose to multiply the top by 4, then that top equation is going to be negative 12x plus 32y equals 88. And if I multiply the bottom by 3, I'm going to get negative 12x plus 9y equals negative 27. And then I can do that little trick. I can see that now my x's are stacked up nicely. The values are the same. They're just not opposite signs. So I can use that little trick I was talking about before and just run a -1 through it, which is just going to change all the original signs, flip them the other way. So these eliminate, and then I can keep going. So those are the hardest type. So hopefully this will help you. Let me know if you need more help or you want more examples on a certain type or whatever.